Your task is to create a bandgap in a two-dimensional photonic crystal. Obviously a bandgap for all possible directions of incidence. And the question is, do you think this will be easier to achieve in a square lattice or in a triangular/hexagonal lattice? So pause the video and see how symmetry can help you answer this particular question. So our goal is to have a bandgap for all possible angles of incidence. So let me just draw a couple of angles of incidence here. So obviously you need to have this happening for full 360 degrees angles of incidence. Let's first have a look at a square lattice. So let me draw a square lattice here, or at least an approximation of a square lattice. Okay. If this is a square lattice, you can play with all sorts of things like the exact dimensions of the rods here, or the refractive index contrast. But the important thing is, again, that you should have a bandgap for all possible angles of incidence. Now, if you take a look at this particular angle here and that particular angle over there, you see because of symmetry that they are the same, right? Because you can rotate over 90 degrees and you have exactly the same situation. By the way, that direction here, 45 degrees, that's not the same direction because the distance from here to here is different from the distance from there to there. There's an extra factor square root of 2 there. But the important part is, as soon as you have a bandgap going for this 90 degrees over here, then symmetry will take over and will automatically give you the full 360 degrees. So here your task is only to create a bandgap over 90 degrees. Let's now see what the situation is for a hexagonal lattice. Let me draw a hexagonal lattice, or again, an approximation, because my drawing skills are not so great. But let's now play the same game, and let's say we manage to create a bandgap in this direction here. What is an equivalent direction? Because of symmetry, now we only need to rotate over 60 degrees before we have a direction which is fully equivalent. So it doesn't look like it completely in my diagram, but obviously you know that if you rotate over 60 degrees for a hexagonal lattice, you will end up where you started from. So in this particular case, you only need to make sure that you have a bandgap over 60 degrees before symmetry will take over and will automatically give you the full 360 degrees. And it's very obvious that making sure that you achieve something for 60 degrees is much easier than making sure that you achieve that same property over a much wider range of angles. And this is why it's easier to create an omnidirectional bandgap for a triangular lattice.